Grade 10, Gauteng, Paper 2, June 2022. Question 5. We're given a list of quadrilaterals and asked to answer the questions that follow. So for this question 5, it's just about recalling the facts that you've learned about the different quadrilaterals. So for the first one, 5.1, we're asked which quadrilaterals have diagonals that bisect the interior angles, and that is only true for square and rhombus. Then 5.2, which of these quadrilaterals have diagonals with the same length? That's true for a square and a rectangle. And then for 5.3, we're asked for which diagonals bisect the area of the quadrilateral, so cuts the area of the quadrilateral in half. And that is true for a square, a rectangle, a parallelogram, and a rhombus. And if you're struggling to understand what that means, you can just draw yourself a little diagram. So this is a rhombus or a parallelogram, it looks like, and you can see that this diagonal on this side, this triangle would have the same area as this triangle, and it would be the same for this diagonal here. That these two triangles are the same size, and of course you know that you can prove that these triangles are congruent in a parallelogram. Okay, then for question 6, we are given a parallelogram PQRS with M on PS such that PM is equal to PQ. So that's PM and that's equal to PQ. And that SM is equal to SR. And then QMR is equal to 90 degrees, that's labeled for us, and Q2 is equal to X. Then we're given some questions. So the first one asks us to determine with reasons two other angles which are equal to X. So I know that Q2 is equal to X. And straight away, because I was told that PQRS is a parallelogram, I know that this line here is parallel to this line here, and there is a line in between joining them, which means that because of alternate angles, I know that X is going to be equal to this angle here. These two are the same size. So that's the first one. I'm going to say that X is equal to M1. So now I know that M1 is equal to X, and I was given in the diagram that PM is equal in length to PQ, and so this M1 and Q1 are angles under opposite equal sides, which means that Q1 is also equal to M1 is also equal to X. So this is 6.1, and the first thing I'm going to say is M1 equals Q2 equals X, and my reason is alt angles. And you always have to give which are the parallel lines, and that is PS parallel to QR. Then I'm going to say that M1, or let's say Q1 equals M1 equals X, and that is opposite angles under equal sides. Then the next question, 6.2, we're asked to determine the size of angle M3 in terms of X, so this is M3. So I was given in the diagram that this line SR is equal in length to the line MR. So in this triangle, if these two lines are equal in length, that means that these two angles are equal in size, right? The opposite angles under equal sides. And that means that whatever angle S is the same value as whatever angle M3 is. And I know from my parallelogram PQRS that the opposite angles of a parallelogram are equal. And I've just found out what Q1 and I found out Q1 in terms of X. I was told that Q2 is X. So I know that if I add Q1 and Q2 together, that's going to be the same as this whole angle S. And then because of the opposite angles under equal sides, I know that angle S is equal to angle M3. So I'll start by saying that angle S is equal to angle Q1 plus angle Q2, and that's equal to x plus x, which is 2x. And the reason is op angles palm. And then I can say that M3 equals angle S equals 2x. And that's opposite angles under equal sides. Then for the final question, 6.3, I'm asked to find the numerical value of x. So I found out that M3 was 2x, I found out that M1 was x, and I was told in the question that M2 is 90 degrees, and these are all angles in a straight line, so I know that they must equal 180 degrees. Their sum is equal to 180 degrees. So I'm going to say angle M1 plus angle M2 plus angle M3 equals 180. And that's angles on a straight line. Then I'm going to substitute all the values that I found. So I found that M1 was x. I was told M2 is 90 degrees. And I found that M3 is 2x. So I add the x's all up on the left-hand side and I get 3x, and then I have 180. I'm taking 90 over to the other side, so it's negative 90, and 180 minus 90 is 90 degrees. And then finally, I'm going to divide everything by 3 to get x on its own, and I get that x is equal to 30 degrees. Question 7, I'm given the parallelogram ABCD, and I'm told that AD is parallel to BC, and that BA is parallel to CD. And we're told to use this information to prove the theorem that states that the opposite sides of a parallelogram are equal. So we can do that by proving the congruency of these two triangles BDC and ABD, right? I can already see that this line here, this diagonal BD, is common, so I've got one side. And then because I'm given these parallel lines, I can use my alternate angles to say that these two angles are equal. And I can also say that these two angles are equal. So then in each of the triangles, I've got 2 equal angles and 1 common side, and that's everything that I need to prove congruency. Then if the two triangles are congruent, that means that this line in that triangle is equal to this line in the other triangle, and then this line in the first triangle is equal to this line in the second triangle, and then I've proved that the opposite sides of a parallelogram are equal. So I'm going to start by saying that BD is common. And for that, I can just write given. Right, then I'm going to say that D1 is equal to B1. And that is from my alternate angles. Right, it's this one. So I'm going to say that alternate angles and AD is parallel to BC. And then similarly, I can say that angle D2 is equal to angle, this should say B2. then I can say that angle D2 is equal to angle B1. Same alternate angles, but now I'm using the other pair of parallel sides, which is the AB and the DC. Okay, then I can say that the two triangles are congruent. So triangle ABD is congruent to triangle DCB, and that's from side angle angle. Right, then from the congruency, I can say that the sides that I want are equal. So that's going to be this one equal to this one, and this one equal to this one. Therefore, AB equals DC, and that's from congruent triangles. And AD equals BC, congruent triangles. Therefore, upsides palm ABCD are equal. Question 8, we're given that ABCD is a parallelogram. That's this one. And that BD and AC intersect at O. And so these are the diagonals of the parallelogram. And I know from my properties of a parallelogram that the diagonals bisect each other. So I can immediately say that OD is going to be equal in length to OB, and that OA is going to be equal in length to OC. So I'm going to fill that in. So this one is the same length as this one, and this one is the same length as this one. Alright, then I'm told that AF is equal to OD. So this one is AF and this one is OD. They've already labeled it for me. And I'm told that CO is equal to FB. That's also been labeled for me. Then question 8.1 asks me to prove that BOAF, which is this one, is a parallelogram. And I can see straight away from the fact that I deduced that these diagonals were bisecting each other, that means that OA is going to be equal in length to FB. Remember, the question told me that this one is equal to that one. And then I knew that my diagonals bisect each other, which means that this one is equal to this one, which means that OA is also equal to BF. And in the same way, I was told in the question that AF is equal to OD. And because this is the diagonal of the parallelogram, I know that it's being bisected by the other one. So this is going to be equal to this. So if the OD was equal to the AF and the OB was equal to the OD, that means that the OB is also equal to the AF. And now I've proved that the opposite sides of this shape are equal, which means that I can conclude it's a parallelogram. Okay, so I'm going to start by talking about my diagonals bisecting each other. So I say that OA is equal to OC, and that's from diagonals bisect in palm, and that palm is the ABCD. And then for the other diagonal, I'm going to say the same thing. So BO equals OD. Okay, then I'm going to say, therefore, AO equals BF, and AF equals BO. Therefore, BOAF is palm. And and the reason is opposites equal. And then for 8.2, I'm asked to prove that AD is equal to EA. Okay, so the first thing I know is that I've just proved that this shape is a parallelogram, which means that this whole side and this whole side are parallel to each other. So I know that EB is parallel to OC. And then in the question, I was told that ABCD is a parallelogram, which means that this side is parallel to this side, but that also means that it's parallel to this whole side here. So then I can say that this whole shape, EBCA, is also a parallelogram, and now I'm going to say it's because of opposite sides being parallel. Both pairs of opposite sides are parallel. So now that I know that this is a parallelogram, I can conclude that the opposite sides are equal. That's from my properties of a parallelogram, which means that this side BC is going to be equal in length to this side EA. But originally in the question, I was told that ABCD is a parallelogram, which means that the opposite sides of ABCD are also equal in length. So BC is going to be equal to AD because of that parallelogram, which means that EA is going to be equal to AD as well. So I'm first going to say that BE is parallel to AC, and that is proven. We proved in the previous question that BOAF was a parallelogram. Then we were told that ABCD was a parallelogram, which means that AD is parallel to BC. And if AD is parallel to BC, then the whole length ED is also going to be parallel to BC. So that's given. Then I can conclude that EBCA is a parallelogram because both pairs of opposite sides are parallel. I should say therefore. Parallel. Okay, and now since this is a parallelogram, I know that EA is equal to BC. That's from Palm EBCA. And then I'm going to say since AD equals BC, that's from Palm, or rather upsides Palm ABCD. Then EA is also equal to AD.